return of these two securities move together, which we call covariance. I had explained the formula, but I haven't taken the calculation as such, although I have taken the calculation of standard deviation. So I will briefly explain to you how it is calculated. You can see here this formula, which simply states that the return of, if there are two securities I and J. So what we do that from each observation of, let us say, security I, we subtract the mean return. And then similarly, if there is another security J, then we subtract from this the mean return. Please recall that in standard deviation, if there is one, then we square these terms, okay? And then add it and then divide by the number of observations of individual security. Now the same formula is used, divided by T, that's the number of observations. So it goes from 1 to T. Now this example I have taken here, that there are two stocks, X and Y. I have just written 12, 16, 19, 21, 20, 10, 11, 9, 16, and 18. So I have taken the average of these. So average of these return is 17.6 and 12.8. I would advise you that please do it manually. Okay. So I have done it here. And then what I have done here is that we have calculated the deviation. dy means your deviations. Deviations means from the mean. So this 12 minus this has been, 12. The first column is 12 minus 17.6. So it will be 0.56. Then the rest also 12 minus this. Sorry, okay. Then 16. The other will be 16 minus this, 19 minus this. Every same way we have also done here. So it is here 12.8 minus 12. 12 minus 12 minus 12.8. So it will be 2.8. The observation is 11 minus this 12 minus 8, and this will go on like this. So it is like, deviation from the mean for each observation we have calculated. And then in this column, what we have done here is that we have multiplied these. These are the product E. In E column is the multiplication of these. So we have added it. Okay. Now for covariance, what you need is that you have to divide this by the number of observations. So number of observation is 5. So we have divided here. So the covariance has come out to be, so it is nothing but the 36.6 divided by number of observations. So we have got it. What I have done further here is that, since if you wish to calculate correlation, the correlation is let us say security I and J or X and Y is simply the covariance of X and Y divided by the product of standard deviation of X and Y. So this I have calculated here. And then the next thing is that what you have to do, that you have to calculate the, so what, using the same data, I have just squared these terms. So and then added here 15.32. If we divide by number of observations, 5. Similarly, if we divide by number, this will be variance. So what I have done here is I have taken the square root of this. When you take the square root of this thing, it will be 3.26 and less. So I have, if you put here this 7.32 and this product of standard deviation, that is 3.26 into 3 divide by this, you will get a correlation of coefficient of 0.6. In other words, if you are given covariance, the correlation coefficient and the covariance, then one can find out in this way by cross multiplying. Now the correlation, what it does, that it shows that there is a positive relationship of 7.36. So what it has done is that it has scaled it on a continuum ranging from +1 to -1. So it is somewhere, 0.36, let us say, the 0.3, 0.63. It is not a perfect, but 63% there is a co-movement, which is a positive co-movement between the security. If it was +1, then it was moving 100% in tandem. If security was to move by 10%, the other security will move by. So there is a positive correlation, but this is not perfect positive. -1 means that both will move. So that is why this is important when we are combining securities, when we are forming portfolio. Because in portfolio risk, what matters is not the individual risk, SD of individual, this is individual risk of, but how the covariance or counterpart correlation coefficient, both are the same thing in used in different fashion. So this is how I have done it, by using the Excel, and you can also find out by manually also. This is not. In Excel, there is a facility that tells us that you can calculate these things by simply, for instance, this formula is there in Excel. If you go there, for example, if I go to calculate so I will just type here covariance. And I will just, highlight this and close this and hit enter. So I'm sorry. What is the issue with this? Close the message. Okay. Just 1 minute, please. There is some time. There is some issue coming up, so I may have to. So there is a formula exactly when you do this thing. I think there is, let me have to get hell with this function, close in filling the insert function. It will sign. Anyway, let me show it on other, because sometimes there is issue. So I will insert, I can show it in another place, no problem. There is issue, I'll come back to that, close it. Just 1 minute, I will close it and then cannot do it. What is the issue? Let me try once again, sometimes covariance. What is the issue with this? Anyway, I will just close down and just restart this thing. So there is a function here. You can see here when you sign equal here and just show this area, this stock the range from A2 to A6, this area, and then B2 to B6. I'm sorry, there was a mistake on my part. That is why this problem was occurring. So this is the covariance, and that is why. So covariance. So the first row array is this. Actually, there was a mistake on my part. That is why it was. And then the second is the stock. Okay. And now I will close the bracket and will enter. And now it is coming out. There was a mistake. Sometime it happens that. And let me remove these things. These. Erase these things. So the same thing, you can do it by this. Similarly, for standard deviation also, one can find out the same thing with equal sign. Now we can go there. For example, here, just have a look here. What I have done here is that there is a function here, SD, and for the population. So equal sign, we start with this, and just when you, the SDP, and now we want to calculate the standard deviation of portfolio X. So we will close the bracket, show the, and hit enter, and you will get it. Similarly, for just you can drag it. That will also show the same thing. I'm sorry. There is no, it's not getting copied. So this again, you, because the data is different actually. So again, I will go here and I will show here the array and close the bracket and hit enter. You will get GSD. Similarly, for correlation, again, two arrows have to be shown. So I will go correlation. Here you can see here, I have used the function correlation. Okay. So there is a function equal sign. When you type here correlation, you will get. So it is showing that array 1 and array 2. The first array followed by comma and then array 2 and then close it. The first array is this. So then second is this. I'm sorry. This is mistake. The first array, comma, and then we go to this array and then close the bracket and hit enter. You get this correlation. So in this way, in the Excel, all these functions are there, but I would advise you that please do manually. What I have done, by calculating it, one by one, just at one stroke, you can get it. So there are several functions in. So because why I am doing this thing, because I will do it later on in my class of portfolio calculation. So this is how we arrive at the covariance and correlation of the stocks, because this is important in order to calculate the portfolio risk. And what I'm going to do next is that I will tell you about the how portfolio returns and portfolio risk are calculated, and based on the discussion on return and the risk SD and covariance. How can we calculate the return of a portfolio when securities are combined, two or more, and how can we calculate the risk of a portfolio like that? And this is based on the discussion about the Markowitz portfolio mean variance theory. If you have any difficulty, you can ask before I move to the other part. So I will stop this thing. I will come back to this thing again. So let me go to the other slide. Why I have done all these things? The simple reason is that as a background, as a precursor to discussion on portfolio risk. Now, the portfolio simply means that when there are two financial securities, they are combined. You know, when when we combine it, then the issue is of return becomes portfolio return. How much return we will get it on that portfolio. If there are two, we will start with a simple case of two securities and we'll extend it to multiple securities. Uh, but the import of the thing remains same. Only thing is the number of securities they go on increasing. So they may be as high as 100,000 securities. So there is no need for calculation of. You'll see later on that as we combine securities of 15, 20, then the risk of the individual risk of a portfolio, the which we call the specific risk, will become negligible, whereas another type of risk, that is why there is no need for calculating all those, but you will get an idea about the portfolio risk and how it is calculated. The calculation of portfolio return is very simple. For example, if we calculate the return of securities, let us say there are two securities R, I and J. Now security I provides 12% return and security provides 15%. Now if we combine these securities, then one issue which we have to decide is how much we are going to invest in these securities, which we call amount to be invested, which we call weight. Okay. For instance, if we decide that 50-50, so 0.5 and 5 into 12%, 0.5 into 15%. So it will be 6 and it will be 7.5. So the total return on this portfolio is expected return will be 13.5. So what is done here is that simply the weightages, the amount invested, these are called weight. And if it may be 0.7, 0.3, so that depends upon, that how much you are going to invest. And there is a mechanism also by which we can decide that how much we have to put in a particular security to attain the maximum return for a given level of risk, or to for we can attain the lower risk per given level of return. So this is how this formula works. So the return on security multiplied by the weightages. So naturally we are assuming that the total amount will equal 1, the weight will be 1, meaning no amount is left, or it may be more than 1 also. For instance, if somebody borrows money, so that will be more than 1. But we will take up this part in the later on when we combine with the risk-free leverage portfolio. You can invest more than 100% also. That will be, and it will be less than 1% also. But for the moment, we are assuming that the amount of money, there is no slack here. The total amount is the 100%. If there are 3 securities, then and equally weighted means, so it means that we divide by 3, so it will be 0.33%, 33% each. If there are 4 securities, it will be 25 equally weighted, I'm talking about each, and so on. The proportion may vary. So it is given here a portfolio consists of 4 securities, expected return of 12%, 15%, 80. The proportion of invested in the security of 0.2, that is 20%, 30%, 0.3, 30%, and 20%. The expected return is simply the weight multiplied by the return, weight multiplied by the return, weight multiplied by the return, and so on. If you do this, the return on this portfolio will be 16.3. Now for the calculation of portfolio return, there is no difficulty. But the moment we go to combine securities, for example, this is expected return, how much we are expecting. What about the risk of this portfolio risk? One thing you may think of that, if we multiply this 20% with the amount which is investing with the individual risk like SD of these individual risk of these securities, we will get the portfolio risk. But this will not tell us about the portfolios, because when securities they are combined, then there is another factor is important which we call covariance. That is why I carried out that exercise to explain to you why covariance becomes important. Not only the risk of individual security is important, but the how these securities, for example, if there are two securities, how these two securities they move together, how this and this move together, how this and this two move together, how the first security with this security move together. So additional terms come in the picture, which we call covariance and covariance. So that is why in order to develop a portfolio risk formula, we have to take into account that. And this is what I am going to explain to you. So this is given here. The risk of portfolio is measured by variance or standard deviation. Now this term I will use interchangeably, variance and standard deviation, because this is nothing but becomes SD. Okay. So although the expected return is the weighted average of the expected return, which I explained to you, that the amount invested multiplied by the return that gives the. But portfolio risk is not the weighted average of individual securities, average of risk of individual securities. That is not the weighted simply average of SD of or variance of these securities, except when the securities are uncorrelated. When the securities are completely and there is zero correlation, then this formula can be worked. But normally it does not happen that the securities are not related, they are correlated, and we hardly find that there is zero correlation. So that is why in order to develop this formula, we have to invoke the term which we call covariance. And that is why the entire exercise I carried out. Develop the equation for calculating, we need information on on weighted individual and weighted co-movement, not only the risk which is measured by SD or variance, but also co-movement, how these securities they move together, and that is included. So by the covariance, or it's a correlation, it is relative measure. I told you that it is scaling of the co-movement on a continuum ranging from +1 to -1. So both our terminologies are same. Only thing is that whether it is absolute number like 37%, 37 we got it, and then we converted it into correlation, then it was 0.63. So that is more meaningful sometimes. But the covariance and correlation. So we have to bring another term, how these, because if we can, why this is important? Because not when you are combining security, then individual risk is important, but also the most important part is the co-movement, because there are various combination of movement which will come into play, and that is used for developing a portfolio risk formula. Now, for instance, before I go to the next slide, I will just like to explain to you that if there are two securities, please keep in mind, the first thing is that we have to take into account how securities 1 and 1 move together. How securities 1 and 2 move together. Then another is that how security 2 and 2 move together. I'm sorry, 2 and 1. 2 and 1 move together. How securities 2 and 2 move together. Now you see that these terms which are coming here, they are nothing but the variance. Because the co-movement of security 1 with 1 is nothing but the variance. 1 and 2 and 2 and 1. Yani how, So so we have four terms which are to be added, multiplied by the weightages, how much money we are investing in one and how much we are investing in security two. So we have to multiply by this, then again by this. You need W1 by this one is square, 1 squared multiplied by this. So four terms have to be added. And this is a special, this takes care of the individual risks. These are the co-movement. It is occurring into, if there are three securities. So we will have 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3, and then 3 and 1, 3, 3, 3 and 3 and 3. So these terminologies, the diagonal term, they are variance because this movement of diagonal, you see that they are occurring two times, 3 and 1, 2 and 1 here like this. So there are 9, 3 into 3, 9 terms. If there are 4, 16 terms like this. But the covariance of each, like 1 and 2 and 3 and 1, they are the same thing, you know. So, and 1 and 1 is same. Please remember the formula for calculation of variance. Variance is, for example, if you want to find out the covariance of security 1 with 1, and remember the formula that of 1 and 2, that it was, you know, x bar and y bar product, you got it, okay. So, and here if it is the same, x and x first, and x and x same, or 1 and 1 same, so it will be nothing but in square the standard deviation, you squared this term, is the same thing. So that is why the diagonal terms are the variance, and off diagonals are, and they are occurring twice. So this is the this example I have taken to explain to you how we develop this formula. Now you see here, the same thing is explained. Now this is a matrix. WD is the amount of money. There are two securities, D and E. So amount of money invested in security D. Okay. Amount invested. And it is the amount of money invested in E securities. Now you see that the first term is R, the covariance of security R, D with D. So it is nothing but the variance. Then this is another covariance of security R, D with E. Then covariance of security E with D. Please remember that these terms are the same thing. They are occurring two times. And this is nothing but the covariance security, which is nothing but the variance. The variance of covariance security E with E, that is itself, is nothing but, so these are the diagonal terms. Now here we have to multiply by the weightages, how much we are. So first we multiply by the row and the column. So it will become WD square, and similarly this will become WE squared. And here because this is occurring two times, so if we take 2 and multiply by we get the covariance of R and D, same thing, and multiply by the weightages which are there, then we get the formula. The same thing has been done here. If we added here, because it is assumed that amount of money invested will be equal 1, so W we have added here. So WD, this is squared naturally, is the variance of the first, that is the covariance of R and D, which is nothing but the variance. And then the other term is that the WD and E, covariance of security E with D, plus covariance of D and this. Please remember that if we take covariance of R and D and both are the same thing, and this is that if we calculate this and multiply by 2, this will give the same thing. And this is the W squared, the RWE, that is amount of money invested and covariance. So this finally we get this formula. So which shows that there are 4 terms to be added. Since it is occurring 2 times, the same thing, this and this. So we multiply by the weightages of D and E, and the twice we make it twice of the calculation which is involved. So and this way we develop this formula. So of if there are 3 securities, then it will be swelled to 9 boxes. It like that. So this is the computation of portfolio, and this is important because later on I will use the matrix multiplication. If the number of securities becomes more, then we can use Excel to calculate the portfolio risk easily by using. So where we will multiply the weightages by rows and columns, and we have got the matrix of variance and covariance, and then we can arrive at the portfolio risk of the portfolio. So this is how this formula is developed, the calculation of the portfolio risk. We will take an example to illustrate this further. Now the same idea has been used here. I explained to you that we have squared this term because it was WD and WD, so we have squared it. So this is the variance of the security, square term, okay. And this is the when the weight in portfolio was WE into WE, we squared it. And similarly, this was occurring 2 times. First it was E and D and D, and so we have done it. So multiply by this. So this was earlier in another case was E and D. Both are the same thing. So we multiply this first and WD and E, and then it is multiplied by 2 to get this formula. Otherwise 4 terms. Otherwise if you remove this thing, then what will happen, that another term will have to be written like this. Same. Here it will be written WE and D, same thing. Covariance RE and RD, same thing. So we, instead of doing this thing, it helps. So in this way, this formula for 2 security case we have developed, and that will make use of in our calculation. So this, and the covariance can also be written, as you are aware of, that it is nothing but the rho. This is the correlation coefficient, and these are the risk of security D, that is the standard deviation, and the standard deviation of the portfolio security E. So it is the product of these. So if we, so the either way we can calculate. Either you are given covariance, then if for example sometime in this formula, so you may not be given covariance. Okay, you may be given the correlation. That correlation is this much. So what we'll do, that here we will write here the correlation, whatever it is given, multiplied by these the standard deviations which we get A, D and E. We will multiply. So let us take a example to calculate this thing, and then we'll go further. Determine the expected return and standard deviation of the following portfolio consisting of 2 stocks. 2 stocks are there. And correlation coefficient is 0.7. Covariance is not given, but you can calculate the covariance. It's not a big issue, you know. You are aware of that the correlation is nothing but covariance divided by the product of standard deviation. So for example, if ABC is given here and XYZ is given, these are 0.4, 0.2, 0.2, and then you multiply by 0.7, then just one. So we can get it. So without going to that, that will become clear, okay, later on. Now let us calculate the expected return. The return of expected return of portfolio is very simple, that 50% here you can see here, 50% in equally weighted portfolio, 50% here, 50% here. Expected return is 14. So what we have done is we have multiplied for expected return. So the formula for expected return, same, 14%, 0.4 or 14. And then what we have done here, that we have taken this, the weightage. We have squared this weightage, and this is the risk of the portfolio point. So we have squared it. And same way, this is the weightage of portfolio, other security XY, and the risk of the portfolio, plus 2 into this, the covariance is 0.75 and 0.22 is the standard deviation. So it has been done 0.5 of one security, and this is the weightages. So the first security 0.5. This is for another correlation coefficient. These are the SD of 1, and these are the SD. So we have multiplied it. So, and we get this, and if you take the square root of this thing, it will become 1.87. Converted into percentage, it will be 18 point. Now this, since the correlation coefficient is 0.75, it is not 1. Okay, so that means that there is a positive correlation, but it is, so that is why the portfolio risk is lower. Otherwise, if you take the risk the lower than the weighted average. Weighted average simply means the for instance, if you multiply by 0.5 into this 2 plus 0.5 into 0.2, so it will become 10 and 10. It will be 20 simply. But here is another term which is nothing but the weight. So that is why what has happened here is that it has brought down the risk of the portfolio to 20% from to 18.7% because of this. So that is why if the two securities, they are perfectly, even not the positively correlated, there is a chance that one can reduce this to lower than if we do not combine it. So that is why the covariance, or the counterpart of it, correlation, is very important, because if we can find other securities which are perfectly negatively, then risk can be reduced to 0. Now the same example is given here, but for the moment, just I will go to just stop this thing for the moment and go to share the Excel sheet with you. Now, same example I have taken from the slides. You see that same thing, 0.5, 0.5, 0.2, 0.2, same, and this was the correlation coefficient, was same example I have given, and this is the formula which we have used it. W1 squared, we did it, 0.5 squared, we did multi, this 0.2 squared, this, then we 0.2 squared, then multiplied by 0.2 squared, then 2 into 0.5 into 0.5 into 0.75 into 0.2 into 0.2, and this is how we got it. Now this formula, you can see here. So I have used it. I have used in Excel. The same thing I have done here. This is also the same thing, just for your explanation, that correlation coefficient is nothing but covariance divided. For example, we have got this thing. If you multiply the correlation 0.75 into this 0.2 into zero point 0.2, you will get covariance. So both are the same. So let us, for example, if you want to use it in Excel, so this can be done in Excel, and this can be done. Let me just remove this thing for you. कलम कागज वगैरह थोड़ा सा लेके बैठिए कैलकुलेट करने के लिए, वरना फिर ये होगा कि समझ में नहीं आएगा ऐसे हवा में. Now this is how I have done. You see that what I have done here, the same thing is a portfolio return, for especially for the what I have done here, that I have used this formula. So let us put this formula here by using this. So we'll start with the equal sign, and then what we do, that we go to the first W1 squared. Okay, so let us say apple, and we square it. Okay, then multiplied by the risk of the SD of this thing. So I have done here, just shown this the cell where it is there. So, and then the next term is plus. Okay. So what then W2 squared. So what I have done here, W2 shown here, B4, just click on and squared this term. Okay, and then it is into just 1 minute, please. We multiply by the weight which is there. Okay, and sorry, this is the second term, and then 2, then multiplied by the W1, this is the weight, then another weight of W2, and then the respective standard deviation. So this is the C3, and then the standard deviation of portfolio 1, and then the next one is, just click here on C4. So you get this formula, and if you hit enter, there is some mistake here. I will have to check it. Okay, B3 is okay, B3 squared into C3, correct. B4 into, this is mistake, I think. Correct. The second term is that B weight, B4 then multiplied by This is the portfolio variance which you are getting it. But if you want to take the square root of this thing, so what we will do that we will here add square root. Okay. Just click here and close the bracket and hit enter. So we are getting this thing. The point it has been rounded off. So it I think there is some mistake. The portfolio risk should be 18.3. Let me check it. B3, okay. B3 squared into B3 squared into C3, correct? Then B4 into C4, correct? Plus 2 into B3, B4. And actually I have missed out this one. So we have to add here the correlation coefficient actually. This has been missed out. This P1, P2 I have missed out. So multiply by this. I think that it is coming out to be almost similar. So if you so it has rounded off, but it is coming out to be 0.9. So you see that what I have done here, that I have used Excel just to calculate this thing. Same thing I have done here, that the square root I have just taken of this variance. So you get the variance, and then if you take the square root, you will get the standard deviation. I will provide this sheet to you. Now I would like to show you something which can be very revealing to you. So I am leaving this thing, just I wanted to show it how can you arrive at the portfolio risk formula. We will do it further. This is not the end of it. This is the beginning. Now if you see here this formula, okay, same thing. B3 squared, this one, and then this is squared, plus B4, this is the, and squared into C4, this is squared, plus 2, we have done it, and then B3 and B4, with B3 and B4, this, and then C6, actually this I missed out, this is C6, covariance curve, okay, and then multiplied by the SD, C3 and 4, and then this, if you do it, then you will get the variance. But if I have taken the square root, one can also do it by separately another cell. For example, instead of directly doing this thing, so one can equal, and then the cell can be shown, and then the square root can be taken. Now let me make some changes and see that what happens. Here correlation coefficient is 0.75. I am keeping other thing constant. Okay, I am just putting here -1. Okay. And let us see what happens. The portfolio risk has become 0. So if we can find out a security which is perfectly negatively correlated, risk can become 0. So this is a perfect hedge situation is there. Now let us put another. Like if I put 1, it is same. That there is no risk reduction. 0.5, 20%, 20%. Okay. So there is no risk reduction. So in combining security, because they are perfectly related, therefore, now let me lower it further. 0.2. It will 15.4%. It means that there is a risk. If you have securities, Apple and Co, 20%, 20%, so it will be 0.154. For example, if I increase it further, 0.7. So you see that the risk has gone up to 18. If you just increase further to 0.9, it is 19.4. It is approaching 1. So it is coming out to be almost like, so it means that is why when I put 1 here, so then it was 20%, same like. So there is no way we can reduce risk if the securities are perfectly correlated. So that is why when securities are perfectly negative, this is very difficult to get it. Only way we can have a we can have a perfectly hedged position is that if we make investment in a derivative security. For example, we buy a stock and we buy an option on certain stock. So we buy a put option on that and buy a stock. So it will be, otherwise most of the securities, they are positively related, but you see that that is why the lower the correlation, greater the chance of risk reduction. And that is why I showed you, for example, 0.5. So risk is lower. For example, it is 0.4, it will go down further. If it is 0.1, this will go down further, 0.40. If you were to buy these securities 20%, so naturally there is a 6% reduction almost of the. So that is why the lower the correlation, greater the chance of risk reduction and diversification benefit when you combine securities into into a portfolio. And this is the reason why I have taken this example to illustrate. If you have any question, you can ask it, okay, before I go further and explain to you. Other things are also there, which I will explain to you.
So this is for 2 securities only, right?
Right now, we are taking for only 2 securities to explain it, but we will use multiple securities as well to illustrate to you, because you know that calculation manually becomes very difficult when you are using beyond 2, 3, 4, okay? But the import of the thing remains same, isn't it? So now here it is 1 and 2, okay? There are 2 securities. Then 3 securities, how many combination will be there? Permutation and combination. If there are 3 securities, then how many correlations will be there?
9.
9 terms will be there, no? So first like security this, then what about 1 and 3 and 2 and 3? There will be 3 exclusive correlations instead of 1, isn't it? And this formula will get expanded further, okay? Same way, the 9 terms we have to add it, and but you know that there are some repetition like 1 and 2 and 2, 1, and then we can multiply. So in that way we can have the formula, but we are not using that, but we will use matrix multiplication in Excel to explain to you how can we use that to calculate further. Because if you understand the central message of why it is beneficial to combine securities when they are not perfectly correlated, because there is a chance of risk reduction. Otherwise, there is no point in forming a portfolio. And how can we reduce risk if we are combining it into a portfolio? And what will be the maximum benefit of portfolio diversification? The maximum benefit will be that if securities, they are not perfectly correlated, +1, like there is no chance. And the maximum benefit will be -1, and minimum benefit, there is no benefit at all, is +1. The story lies somewhere in between. The lower the correlation, greater the chance of risk reduction. Higher the correlation, lower the chance of reduction. I will see later on if the securities, the portfolio becomes more than 15, 20, then you can reduce risk of a portfolio, but there are certain kind of risk which will stay, which we call market risk. No matter you have 100 securities in your portfolio, thousands of securities in your portfolios, universe of securities, global all the securities of the universe, but you will not be able to reduce market risk later on. But here I'm trying to explain is that what are the benefits of why combining securities in a portfolio leads to reduction in risk, what we call diversification benefit. You can get higher return with lower risk. For example, it is not affecting the return, but what is affecting here is that given the other thing, if the lower correlation is there, the risk is getting reduced because of that. And that is beneficial for investment. Okay. So let us stop for here, and then let me move to my PowerPoint slide. I will revisit this thing tomorrow once again. So I will stop this thing and we'll go to my PowerPoint slide to explain this. So I think that is. Now this is how I developed the formula, and you know that based on these combination of securities, for example, this example, if you take it, which is called efficient frontier, efficient frontier is that if there are two parameters, one is the expected return, another is the standard deviation correlation. So you see that given these things, that is the 20% is the SP of these, and this is the correlation of -0.2. Now there are various proportions which we can be invested. For example, portfolio, one can invest entire 100% in one portfolio, one security. So one will get 12% return, and risk will be 20%. Then 90% in A and 10% in. These are the calculated based on this. Okay, so return will be 12.8 and risk will be same formula, which if the other one this much and like this. So same way it is going on 50-50, 25 in 1% and like this. So this will be situation. And the other extreme, there are two extremes. One is that entire amount is spent in security A and entire amount is spent in security B. So naturally, if the entire amount is spent in security B, 20% is the return. 20% is the return of security, the other security, and will be the 40% will be the risk of that security. First one 12%, and in between the story is that when you are, and naturally in a portfolio, you combine two securities, not that you make investment here. So based on this thing, it has been calculated. Now this investor is faced with situation when there are various combination of risk and return available. Like two security case we are taking it, but it may be number of securities. So a combination of risk and return comes in. Now what should be the criteria for choosing a portfolio when you are having a particular level of risk of a portfolio and particular type of return? That is depicted on a graph which we call efficient frontier. Like if this is the return and this is the risk. Risk is measured by a portfolio, by the portfolio standard deviation. So for example, the first security case was that 12% and 20%. The other case was that 100%, 20 and 40 was there, this case. Now, if the securities are perfectly correlated, then you will move along this line. There is no chance of risk reduction. But if the securities are, for example, -2 or minus -0.2, something like that, then we will find that there is a chance of risk reduction. For example, any movement on this, if you move up here, this is expected return, given the same level of risk, it will lead to more, return given the same level. For example, this, you see that zero point 0.3 and 0.2. 0.2 has got this much risk, okay, and return is this much. 0.3 is higher, slightly. So it is providing with the same level of this more return. So for example, if there is another point here, not shown here. So if this point is providing higher return given the same level. So the criteria is that if there are various combination of risk and return, let us take risk is 20%, 20%. There are two options. Return is 18% and 20%. Risk is same. So there are two portfolios. One is providing 18% return, another is 20%. Risk is of both the portfolio is same. So any portfolio which offers higher return given the same level of risk, it will be preferred. For example, this portfolio B will be preferred over A because it is providing higher return with the same, because it is providing lower return with the same level. Now take another case. Now let us keep return constant 20-20 and vary the risk. Let us say risk is 16% of one, another is 14%. So now the return is same. The portfolio which is providing lower risk should be preferred, like here B. This will be preferred because it. So now the criteria is that, for example, by using various combinations, any portfolio which offers higher return given the same level should be preferred. Similarly, any portfolio which provides the lower risk for given level of return should be preferred. Why? This is because you know that investors, if they are risk averse, it is assumed that they would like to have higher return for a given level of risk, or the other way around. That it will not be the case. For example, this case, naturally expected return and risk are there moving in tandem. So there is with combined portfolio, there is no chance. Although risk and return should go in tandem for market risk. Whereas the portfolio combining of security offers a chance of risk reduction. And that is why. So the criteria becomes like this. For example, these are the various combination of different degree of correlation. I have showed you in Excel also that when we have we had a securities which were perfectly negatively correlated, then the risk had become zero. This one, there's a chance. And if they are perfectly they are moving, there is no chance of reduction. So if it is zero, then it may be bent. It may reduce the risk, it may not. But if there is the securities are less than perfect, then there will be a bend and there is a chance. For example, if you move on the vertical axis more and given the same level of, for example, if any the combination provides the higher return given the same level, it should be preferred. So securities which are not perfectly correlated, then they offer a chance. And these are the various combination depicted on a graph which shows that what will happen, because this was the case when we saw it, that risk has become zero when -1 was there. And so perfectly, and this was the case when it was perfectly, so there was no chance of reduction. So the story may lie somewhere in between, that we cannot get the securities which are perfectly correlated but less than perfect, but there is still a chance of risk reduction like that. This is known as the efficient frontier, and like this I will explain to you further in my next class, and then I will go on to Excel sheet to explain you. We will see that, we will depict it on there in Excel using that. I think we should stop for today, and we will continue from where I have left it to explain you further. Because if no, these are the concepts which are slightly involved concepts. If you come across for the first time, it may take time for you to appreciate it. So some 14, 15 students out of class of 40, I think 40 something like that. So good luck to them, and I think that all these 14, 15 people who are joining the class, they are only interested in knowing. Otherwise, there are issues of online COVID and this thing, and I think that is now everything has an expiry period. You know, LBI has an expiry period. So if they do not wish to, but you know that I must tell you that my assignment will be based on this thing, and I will not, be lenient in that. So if you are not attending classes, if you do not follow it, then it is your headache. So with this, I close and will